Welcome back students. As you know, we are doing chapter 3 pair of linear equations in two variables. In the last lecture, we studied algebraic method for obtaining solution of pair of linear equations in two variables. Substitution method, elimination method and cross multiplication method. Now in this lecture, we are going to study some numericals related to this methods and then we'll have to move to word problems. But before starting word problems, you need to study how to form the equations with the given situation. So in this lecture, we will study how to form the equations along with some of the questions related to this method. Example 2. This question we have already done. It was related to graphical method. But in example 9, this question is again used. So I am taking this question again. Romila went to a stationery shop and purchased 2 pencils and 3 erasers for rupees 9. Her friend Sonali saw the new variety of the pencils and erasers with Romila, and she also bought 4 pencils and 6 erasers of same kind for rupees 18. First of all, we need to form the equation. Now here two things were bought, pencils and erasers. So let x be the cost of one pencil and y be the cost of one eraser. Romila purchased 2 pencils and 3 erasers for rupees 9. So our first equation will be 2x plus 3y is equal to 9. And Sonali purchased 4 pencils and 6 erasers for rupees 18. So our second equation will be 4x plus 6y is equal to 18. So the equations are 2x plus 3y is equal to 9 and 4x plus 6y is equal to 18. Now we will solve these equations by substitution method. And students, you know, for the substitution method what you have to do, you have to obtain value of one variable from any one of the equations. So here we will obtain the value of x from equation 1. So we will get x is equal to 9 minus 3y by 2. Now the next step is you have to substitute this value of x in equation number 2. So we will get 4 into 9 minus 3y by 2 plus 6y is equal to 18. So we will get 18 minus 6y plus 6y is equal to 18. That is 18 is equal to 18, which means that this statement is true for all values of y. So we did not get any specific value of y, and because of that we cannot obtain specific value of x also. Now why this situation has arisen? This situation has arisen because both these equations are same. Look at both the equations properly. You can see that in the first equation it is 2x and in the second equation it is 4x. In first equation it is 3y, second equation 6y, first equation 9, second equation 18. So if we take out 2 common from second equation, then both equations becomes same, which means that lines representing both the equations in the graph will coincide each other, and you know that if they coincide each other then they may have infinitely many solutions. Because of that we are not able to get a specific solution or value of x and y. Example 3. This question also we have done when we were doing graphical method, but they have used this question in this example, so I am taking this question again. Two rays are represented by equations x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 is equal to 0. Let us obtain the solution for these equations. So the equations are x plus 2y minus 4 is equal to 0 and 2x plus 4y minus 12 is equal to 0. Now again we will use substitution method and will obtain the value of x from equation number 1. So x will be 4 minus 2y. Now what you have to do? You have to substitute this value of x in equation number 2. So we get 2 into 4 minus 2y plus 4y minus 12 is equal to 0. On solving we will get 8 minus 12 is equal to 0, which means that minus 4 is equal to 0, which is not possible. Therefore, the equations do not have a common solutions. So the two rails will not cross each other. Example 16. For what values of k will the following pair of equations have infinitely many solutions? So here two equations are given, kx plus 3y minus k minus 3 is equal to 0 and 12x plus ky minus k is equal to 0. and we have to obtain the value of k. The condition given to us is they have infinitely many solutions. So, first of all we will find a1 upon a2, b1 upon b2, c1 upon c2. For this we have to solve compare equation 1 and equation 2 with the standard form, that is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. On comparing we will get a1 is equal to k, b1 is equal to 3 and c1 is equal to minus of k minus 3. Similarly, a2 is equal to 12, b2 is equal to k and c2 is equal to minus k. So, a1 upon a2 is equal to k by 12, b1 upon b2 is equal to 3 by k and c1 upon c2 is equal to k minus 3 by k. Now, the equations are having infinitely many solutions, and for this the condition is a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. Right? You know the condition. So, we get k by 12 is equal to 3 by k is equal to k minus 3 by k. First, we will consider the case a1 upon a2 is equal to b1 upon b2, that is k by 12 is equal to 3 by k. On cross multiplication, we will get k square is equal to 36, which means that k is equal to plus or minus 6. Now, consider b1 upon b2 is equal to c1 upon c2, that is 3 by k is equal to k minus 3 by k. By cross multiplication we will get 3k is equal to k square minus 3k, which means that 6k is equal to k square, which means that k is equal to 0 or k is equal to 6. Therefore, the value of k which satisfies both the condition is k is equal to 6. Example 15. For which values of p does the pair of equations given below has unique solution? The equations are 4x plus py plus 8 is equal to 0 and 2x plus 2y plus 2 is equal to 0. Now, here it is given that the equations are having unique solution, that is only one solution, and for the equations having unique solution the condition is a1 upon a2 is not equal to b1 upon b2. So, first of all let us find a1 a2 and b1 b2. On comparing with the standard form, we will get a1 is equal to 4, a2 is equal to 2, b1 is equal to p and b2 is equal to 2. Now, substituting the values in the condition, we will get 4 by 2 is not equal to p by 2. On cross multiplying, we get 2p is not equal to 8, which means that p is not equal to 4. Therefore, for all values of p except 4, the given pair of equations will have unique solution. So, students, these were some of the examples of your textbook related to algebraic method for finding the solution of pair of linear equations. Now, we are moving to word problems. But before starting the word problems, you need to know how to form the equation from the given condition. So, first of all, we will learn how to form the equation and then we will move to word problems, because if you don't know how to form the equation, then you won't be able to solve any of the word problem. So, first of all, it is very much necessary to know how to form the equation from the given condition. The cost of 5 oranges and 3 apples is rupees 35 and the cost of 2 oranges and 4 apples is rupees 28. So, we have to form the equations with this given condition. Now, here first of all you have to say what is given. The total cost of 5 oranges and 3 apples is given in the first case. So, first of all we should know what is the cost of 1 orange and what is the cost of 1 apple. So, let us suppose that x is the cost of 1 orange and y is the cost of an apple. The cost of an orange is x. So, the cost of 5 oranges will be 5x. Cost of an apple is y. So, the cost of 3 apples will be 3y. Now, the total cost of 5 oranges and 3 apples is 35. So, 5x plus 3y is equal to 35, which is our first equation. Similarly, cost of 2 oranges and 4 apples is rupees 28 in the second case. So, 2x plus 4y is equal to 28, which is our second equation. Next question is, Rakesh purchases 15 pens and 20 pencils. He has to pay rupees 190 for it. The sum of costs of a pen and a pencil is rupees 11. obtain the pair of linear equations into variables. So here also let the cost of a pen be rupees X and cost of a pencil be rupees Y. Now in the second situation it is given that cost of a pen and a pencil is rupees 11. So the equation will be X plus Y is equal to 11. Now Rakesh paid rupees 190 for 15 pens and 20 pencils. So the next equation will be 15x plus 20y is equal to 190. Let us see another question. Champa went to a sale to purchase some pants and skirts. When her friends asked her how many of each she had bought, she answered, the number of skirts is 2 less than twice the number of pants purchased. Also, the number of skirts is 4 less than 4 times the number of pants purchased. Now here you can see that the condition given to us is related to number of pants and number of skirts she purchased. So let X be the number of pants she purchased and Y be the number of skirts she purchased. Now let us see the first condition. The number of skirts, which is Y, is 2 less than twice the number of pants. Twice the number of pants means 2x. So number of skirts, that is Y, is twice the number of pants minus 2. That is Y is equal to 2x minus 2, which is our first equation. Now let us see the second condition. Number of skirts, that is Y, is 4 less than 4 times number of pants. 4 times number of pants is 4x. So number of skirts is 4x minus 4. That is Y is equal to 4x minus 4, which is our second equation. Next is the ratio of present ages of a mother and her daughter is 8:3. After 5 years, the ratio of their ages will be 9:4. Find their present ages. So the condition given to us is related to age of a mother and a daughter. So suppose that present age of mother is X years and present age of a daughter is Y years. Now it is given that ratio of present ages of a mother and a daughter is 8:3. So X by Y is equal to 8 by 3. On cross multiplying we will get 3x is equal to 8y. So we can write 3x minus 8y is equal to 0, which is our first equation. Now after 5 years, the ratio of their ages is 9:4. Present age of mother is X. So after 5 years, the present age of mother will be X plus 5 years. And after 5 years, the present age of daughter will be Y plus 5 years. So according to the condition, X plus Y upon Y plus Y is equal to 9 by 4. On cross multiplying we will get 4x plus 20 is equal to 9y plus 45, which is equal to 4x minus 9y is equal to 25, which is our second equation. So this way you have to form the equations with given conditions. The unit digit of a 2-digit number exceeds the tens digit by 2. Find the number if it is 4 times the sum of its digit. So here we have to form only one equation with the given conditions. For this, first of all, let us discuss a 2-digit number in detail. Students, let us consider a 2-digit number, say 72. So here 2 is unit digit and 7 is tens digit, right? You know this. Now this 72 can be written as 70 plus 2, okay? This can be written as 7 into 10 plus 2, right? Now consider another 2-digit number, say 54. The unit digit is 4 and tens digit is 5. So we can write this 54 as 50 plus 4. This can also be written as 10 into 5 plus 4. Now if we want to obtain a standard form of a 2-digit number from these two equations, can you obtain it? Just see. Any 2-digit number can be represented as 10x plus 5, 10x plus y, where y is a digit at unit place and x is a digit at tens place. So the general form of any 2-digit number is 10x plus y. This you have to keep in mind. Now our question is, the unit digit of a 2-digit number exceeds the tens digit by 2. find the number if it is 4 times the sum of digits. So let x be the digit at tens place and y be the digit at units place. Now unit digit exceeds the tens digit by 2. Tens digit is x. Exceeds means more. So unit digit is equal to tens digit plus 2, that is y is equal to x plus 2, which is our unit digit now. Now we know that a 2 digit number can be represented as 10x plus y, that is 10x plus x plus 2, and sum of the digit is x plus y, that is x plus 2. Now it is given that the number is 4 times the sum of its digits. So according to equation 1, the number is 10x plus x plus 2, and according to equation 2, the sum of digits is x plus 2. So 10x plus x plus 2 is equal to 4 into x plus 2, or you can say 10x plus y is equal to 4 into x plus y, which is our equation. So students, I hope you might have understood with this examples that how to form an equation when the given with the given conditions. Now in the next lecture we will continue with the word problems. With this we conclude our lecture.